Today we're going to talk about section 7.4, special right triangles. Our goal today is to solve special right triangles. The first special triangle we are going to talk about is the 30, 60, 90 triangle. And as you can see on the right here, the pattern for the 30, 60, 90 triangle is as given. The side opposite of the 30-degree angle is the shortest side. We label that as x. The hypotenuse, which is located between the 30 and 60, we call 2x. It's twice as long as the short side. In solving using the Pythagorean theorem, we find that the side, the long leg, if you will, the side opposite of the 60-degree angle, is x root 3. This is true for all 30, 60, 90 triangles. So we will apply this pattern to all. When solving on something like this where it says find the value, typically what we do is we write the pattern of the 30, 60, 90 triangle inside. So we have x, hypotenuse of 2x, and a long leg of x root 3. We write that on the inside and determine which piece of information we are given. In this case, we are given that 2x equals 12. And we will solve and find that x in terms of the pattern is 6, which means our short leg is 6. But in terms of this problem, it does not ask us for the short leg. It asks us for the long leg, which all we need to do then is plug into the pattern x root 3, and we find that the long leg is 6 root 3. Does not matter the orientation of the triangle. When we are finding the value of x in any 30, 60, 90 triangle, we are doing the same thing. So first thing we are going to do is we are going to copy the pattern of our special triangle to the inside of the triangle. And as we can see here, we are given that x root 3 equals 40. And now we are going to divide by root 3. And we get that x equals 40 root over root 3. Now, one thing we cannot do is leave a radical in the denominator. So, in order to remove this, we need to complete a process called rationalizing the denominator. So we will multiply by root 3 over root 3. Our numerator is then 40 root 3. In the denominator, root 3 times root 3 equals root 9, which is just root 3. So we find that x is 40 root 3 over 3. But in this case, that is not the side it's asking us for. It's asking us for the hypotenuse, which is twice that. So this side is 2 times 40 root 3 over 3, which looks complicated, but really 2 times 40 is 80. So this becomes 80 root 3 over 3. 80 over 3 does not reduce, so that would be our solution. When we look at the next one, same process. The side opposite of 30 is our shortest, so that's x. Our hypotenuse is 2x, and our long leg is x root 3. Again, this situation, we are given that 2x equals 15. Divide both sides by 2, and we get x equals 15 over 2. Now, we are going to want to leave this as a fraction. It'll make our life easier. So again, our short leg is 15 root 2. But again, as in the previous examples, this is not the leg we are solving for. We are trying to find the long leg, which we know to be x root 3. So we're going to plug 15 over 2 times root 3. Now, realistically, we'll just write this as 15 root 3 all over 2. Either one of these work. You can write it as 15 halves root 3 or 15 root 3 over 2. We do not, however, write 7.5 root 3. You need to leave it in fraction form if it's not a whole number. And our last example. And again, we write the pattern on the inside. The short leg is x, hypotenuse 2x, and our long leg is x root 3. In this case, we are given that x is 1,000. So that means our long leg is just going to be 1,000 root 3. And we are done. In this case, we'd put feet because there's a unit on it. And we would be done with that problem. Our next special triangle is the 45, 45, 90 triangle. In this pattern, we have two sides that are congruent. So we know that this would also be called the right isosceles special triangle. So our two sides again are congruent, x and x, and our hypotenuse is x root 2. So this first one, there are two different ways you can be marked that this is a right isosceles triangle. They could mark this by having two congruent sides, which we do in this case, or they could mark two congruent angles like that. Either way, our pattern stays the same, x, x, x root 2. One side is 3, the other side is 3, and then the side length root 2. That would be your exact answer if you are looking for a decimal answer, which this case says to the nearest tenth. We will round that using our calculators to be 4.2. Another example. With this triangle, we have a side length of 4.7. So if one side is 4.7, so is the other. And the hypotenuse then is the side length root 2. So we'll take 4.7 root 2 into our calculator, which is approximately 6.6, rounded to the nearest tenth. And two last examples. Solve for the missing lengths. This directions ask for exact and approximate answers. The first problem here, we have that the side length is 8.3. We have that they are both sides are congruent, so we know this is isosceles. So we're going to have x, x, and x root 2. The side length is 8.3. So we'd have 8.3 root 2, which is approximately 11.7. Over here, on the one on the right, we have our pattern, x, x, and x root 2. So we have that 7 root 2 equals x root 2. So again, we need to solve for x. So we're going to divide both sides by root 2. They cancel, and we get that 7 equals x. So both sides of our triangle has a length of 7 units.